Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The product shown is a cyclic carbonate, 1,3-dioxolane 2-1, which is a 5-membered cyclic carbonate formed from ethylene glycol, HOCH to CH2O, and a carbonyl source. The product has the structure where both oxygen atoms of ethylene glycol are connected to a single carbonyl carbon, C is equal to O, forming a cyclic carbonate ring. Moving on to the next step. Identify the product. The product is ethylene carbonate, a 5-membered cyclic carbonate with structure CH2O/C is equal to OCH2O, a cyclic structure where both OH groups of ethylene glycol have reacted with a carbonyl source. Moving on to the next step. Determine what carbonyl source, A, reacts with ethylene glycol, HOCH to CH2O, in pyridine to give a cyclic carbonate. The cyclic carbonate contains the OC is equal to O linkage, meaning the carbonyl carbon in the product came from reactant A and it must have provided AC is equal to O unit that reacted with two OH groups. And for the final step, A, CH3C is equal to O, CH3. Acetone, a ketone, does not react with diols under pyridine conditions to form a cyclic carbonate. It can form a cyclic acetyl ketal, but that would give C is equal to O replaced by C, or 2 with no remaining C is equal to O in the ring. B, COCl2, phosgene is ClC, is equal to OCl. It reacts with ethylene glycol in the presence of pyridine, which acts as a base to neutralize HCl. The two OH groups replace both Cl atoms, forming the cyclic carbonate CH2O, C is equal to OCH2, ethylene carbonate. This is a well-known synthesis of cyclic carbonates. CH3C is equal to OCl, acetyl chloride. This would give an ester linkage, not a carbonate. Reaction with one OH gives an ester. It cannot form the cyclic carbonate with OC is equal to O linkage since there is no second leaving group on the same carbon. D, CH3C is equal to O-OH, ethyl acetate. This is an ester that could undergo transesterification, but it would not produce a cyclic carbonate with AC is equal to O between two oxygens. Only phosgene, COCl2, has two leaving groups, two Cl atoms, on a single carbonyl carbon, allowing both hydroxyl groups of ethylene glycol to displace them, forming the cyclic carbonate product with pyridine acting as acid scavenger. Why other options fail? Acetone, A, forms acetyls not carbonates. Acetyl chloride, C, has only one reactive site and would give a monoester. Ethyl acetate, D, would not readily form a cyclic carbonate under these conditions. Therefore, the correct answer is B. Therefore, the correct answer is option B.